Okay. In this one, we're going to take a look at geometric and arithmetic sequences in series and trying to find the sum of the first n terms of an arithmetic series or geometric series. So we've got two formulas to define this. The first one is given to us right here, n over 2, and then you just add the first term and the second term. For a geometric series, you take the first term and you multiply it by 1 minus r to the n over 1 minus r. So it says find the first n terms of an arithmetic or geometric series. So here, the first thing that we're going to need to do is figure out, is this an arithmetic or a geometric series? And when you take a look, if we subtract this, 30 minus 10 gives us 20. 90 minus 30 is 60. We know that this is not an arithmetic series because they do not increase. If we take the differences, they're not constant differences. But what we can see that is if we take a ratio, 30 divided by 10 is in fact 3. 90 divided by 30 is in fact 3. So we know that this is a geometric series, right? So how do we find the nth term of a geometric series? We're going to use this formula right here, which says take your first term. So actually, real quick, before we do this, it looks like the two things we need are our first term, which is 10, and our common ratio, which is 3, because again, it's going up by a multiple of 3 each time. To find the first n terms of a geometric series, we define that by taking the 10th term, or the number 10, or the first term in the series, and then it's 1 minus 3 to the n power over 1 minus 3, which gives us 10 times 1 minus 3 to the n over 1 minus 3 is 2, right? Now, I can cancel the 10 and the 2, and we can simplify this. This becomes a 1, that becomes a 5, which simplifies this to 5 parentheses 1 minus 3 to the n power. And then I'm just going to leave it like this because you might be tempted to distribute the 5 in there, but you cannot multiply 5 and 3 to the n power. So this is as far as we can take this. And let's just figure this out. Let's say I wanted to find the sum of the first 3 terms. Well, I can look at it right now. 10 plus 30 is 40. 40 plus 190. We know the sum of the first 3 terms should be 140. Let's work this out and make sure that that's what we get here. 5 parentheses 1 minus 3 to the third power, which is 5 parentheses 1 minus 3 to the third power is 27, right? And then 1 minus 27 is 26, and 5 times 26 is 130. Oh, wait. This is 130. And I'm sorry, I didn't do my math correctly up here. 10 plus 30 is 40. 40 plus 90 is 130. So we did find the correct number in this, the sum of the sequence. It's just an easier way, especially when these get a lot bigger. So if we're going to find the first 10 terms, some of the first 10 terms in the series, that would be how we find this. All right, so let's take a look at this next one. Let's decide if it is a arithmetic or geometric series. If I look, let's first check for arithmetic series. If I do 1/4 minus 1/2, I get negative 0.25 or negative 1/4 when I subtract these two. And when I take 1/8 minus 1/4, I get negative 1/8. So this is not a arithmetic sequence. We can tell because it does not have a common difference. So let's check with geometric. If I take 1/4 and I divide 1/2, 1/4 divided by 1/2 is 1/2. We can see that this is decreasing by a 1/2 each time, but just to make sure, 1/8 divided by 1/4 when I work this out. If you do this in the calculator, please make sure you use your fraction button or use some parentheses. I also get 1/2. So we know that the first term in our sequence is 1/2, and we know that the common ratio is also 1/2. And we know that this is a geometric series, so let's go ahead and find the sum of the first n terms. So the sum of the first n terms, which we will denote S subscript n, is given by the first term in the sequence is 1/2, and then it is 1 minus r, which is 1/2, to the n power over 1 minus 1/2. All right, let's simplify this a little bit further. When I subtract 1 and 1/2 in the denominator, we're going to get 1 minus 1/2 to the r power over 1 minus 1/2 is 1/2. And then these are going to cancel out, right? Because I have a 1/2 on the outside, I have a 1/2 in the denominator, so those cancel, and our formula is 1 minus 1/2 raised to the n power. And that's how we would find the sum of the first n terms in the sequence, and now we could use this generalized formula to find the sum of any terms that we wanted in the sequence. All right, part C. Let's check for arithmetic sequence. 6 minus 2 is 4, and then 18 minus 6 is not 4. So we know this is not arithmetic sequence. Let's check for geometric. Is 6 divided by 2 is equal to 3. 18 divided by 6 is also equal to 3. So we know this is a geometric series. Our first term in the series is 2. And the r term in the series is, what is the common ratio? It's 3, right? All right, let's go find the nth term in this series. It's going to be the first term in the series, which is 2. Parentheses are 1 minus 3 to the n over 1 minus 3, which this will keep working to 2 parentheses 1 minus 3 to the n power over 1 minus 3 is 2. And then our 2's are going to cancel here, right? So these 2's cancel, and we end up with just 1 minus 3 to the n power. All right, one last one. Let's check for arithmetic series. 8 minus 3 is 5, and 13 minus 8 is 5, and 18 minus 13 is 5. So we know that this is an arithmetic sequence, right? So this is arithmetic. That should be an I for arithmetic. Sorry about that. All right, so we're going to work with this arithmetic formula right here. So it's n over 2, and then a1 plus an. So we've actually got to find a couple things. We've got to find our first term. And we know our first term is given by the first term in the series, which is 3. And now we got to find the nth term. And remember, how we find the nth term is, according to the last video, if you go up here, we can see the nth term is given by the first term plus d parentheses n minus 1. Where d is that common difference. So we know our common difference is 5 here, right? So it is going to be, let me scroll down a little bit. We find this by taking our first term, which we just said was 3, and then it is plus d, which is our common difference, 5, parentheses, and minus 1. Let's work this out. Bring the 5 in there. It's going to be 3 plus 5n minus 5, which gives us 5n minus 2 is the nth term of the sequence. All right. Going back to our formula, it is the way we find the sum of the first n terms of the sequence. It's n over 2, parentheses, our first term, which is 3, plus our nth term, which is 5n minus 2. And then we're going to combine like terms. So it's going to be n over 2, and then 3 it's going to be 5n plus 1, right? And now I could distribute this in further, but I'm just going to leave this as it is. Again, if you want to distribute the n over 2, you can, but it's a little bit easier if we have to find a specific term to just plug the number in here. So this is as far as we're going to take this.